Let's work on a series of problems here about present value and future value. We have 4. Number 1 says that Janelle Carter is going to deposit $9,750 today, and she's going to earn 12% compounded annually. And so how much will that grow to in 17 years, from 2000 to 2017? And it's annual compounding, so we don't have to divide this and multiply the number of periods out, just annual. And so we want to know what it will grow to. We want to know this future value, so that's what we're missing. And there's no payments in between. There's no deposits or interest payments or any series of things happening over and over. We don't have an annuity. We have a lump sum problem, and we're missing the future value. So we're going to go to the future value table to get the factor we need. Let's get our factor. All right, 17 years at 12%. Go on down here. 17 years looks like 6.86604. All right, so then we would take the present value times our factor and get our future value. And that future value needs to be bigger than the 9,000, right? Or else you've used the wrong table. Let's look at number 2. Mike Smith deposited $21,600, January 07. Okay, another present value amount. And it's accumulated to a future value of $42,486. And they don't give us the table factor, and they want us to know, let's see, how many years was this? It's 10 years, okay. And they want to know the interest rate. So we have to solve for the factor. So the way this works, algebra-wise, times something we don't know, gave us that 42,486. So we solve for that factor by taking that, dividing both sides by the 21,600. And we get the 1.966 or 94. All right, so we're going to go to the table and look across 10 periods and try to find something pretty close. So here we've got 10 periods. I'm scanning, and it looks like we get somewhere between 7 and 8%, probably closest to 8%. 7% if we're rounding, if they wanted it in whole amounts. So just over 7% would be a real good estimate. Okay. Let's look, and we use the future value of the table just like we did the other one. All right, and let's see here. Number 3, we made another deposit at the beginning. Lots of deposits happening here. The bank pays 8% compounded annually, and it builds to $15,000. They don't tell us what they deposited here. They tell us a deposit was made, but not the amount. And 8%. How many years do we got here? They deposited 7 years earlier. The deposit was made in January 2010, 7 years before it accumulated to $15,000. So how much did they originally deposit? So we know the future value, no payments in between or deposits or series in between, so it's not an annuity problem. We need the present value table to solve for that. All right, let's go get that. Present value table. Okay, so 7 periods, 8%. Looks to me like 58,349. All right, and so the future value times that table gives us that 8752. All right, now for number 4, Nancy Holmes is depositing $5,800 now. And the bank's paying 10% annual, okay, and it grows to be $15,026. And so they want to know how many years has it been invested. So again, similar to question 2, we need to solve for the factor. So that present value times some kind of factor gave you the 15,000. So like we did before, we took the future and divided it by the present to get the factor, 2.59069. And now we're going to go to the table, and we're going to go down the 10% column until we find 2.59. All right. 10% column until we find 2.59. There we go. 10 periods. Let me know if you have questions.